Hi, I'm Katie Sanders, and today I'm presenting on where travelers travel to in 2023 based on the travelers' demographics. So, the background and significance of this is that the world is opening back up again from the pandemic, and there is an expected increase in travelers these coming years. The objective was to find a suitable new travel plan to spend my money on and encourage. This study helps me plan my next travel destinations in terms of budget, destination, duration of time, and the people I expect to see in that area, like gender and age. And then obviously when traveling to a new destination, factors like safety and affordability are a big importance in determining where to travel. My hypotheses are the older a traveler gets, the more they spend on their travels due to like comfort, as well as like you don't want to stay in hostels once you hit like 50 years old. So obviously you're going to be spending more to get a hotel or something. Gender and age have an association to the dataset population, and gender has a role in determining how much you spend on a trip when traveling. Then there is no significant difference between cost and destination. Cost is relatively the same when traveling to different continents. And the last one is the longer you stay on travel, the more it costs. And the overall goal is to create enough data analysis on the data set taken in 2023 on a population of travelers to determine where I should travel next. My data set. The study is done on 139 subjects, but I will use 137. Subjects range from 20 to 58 years of age, and the monetary value spent is in USD dollars. The day duration is in days, age is in years, gender male and female, and you can either be traveling to Europe, Asia, South America, or North America, or Australia, because I converted all the countries that the dataset provided to the continents that they were a part of, just to simplify it down. The modifications that I did was change countries to continents and all monetary values in euros or pence or anything to USD. The variables I used was the qualitative variables were gender, male and female, continents, Europe, Asia, South America, North America, Australia. Quantitative values, age to 20 to 58 years of age, day duration, and cost in USD. So here is the traveler's data set, and I took the mean standard deviation, coefficient of variation, standard error, and 5-number summary. And this is a table 1 that was in my report. So this depicts there are 49 the mean GPA overall in the traveler's data set, its day duration of travel is 7.6 days, age that travels is 33 years old, cost is around $1,892.88 in USD. And this just shows the mean. Figures 1A, 1B. 1A depicts a bar plot displaying frequencies, the cost for destination as the destination sites for travel get to Europe and Asia. More popular places travel, so does the increase in cost. Figure 1B is the mean bar plot of cost versus destination, the continent the traveler decided to travel. This straight line can be drawn through all 5 of the continent's error bars, indicating that there is no significant difference between the destination tourists want to travel to compared to cost. Figure 1C is a t-test. Shows the relationship between cost and destination of the most popular continent, Europe, and the least popular continent to travel to is South America. And it also shows that through the t-test relationship, the test is 0.549679, and the p-value is 0.585147, which kind of makes it insignificant because of the fact that the p-value is greater than 0.05. Next, we have the ANOVA table test. And the ANOVA test, relationship between cost and destination at a p-value of 0.300164 and an f-value of 1.23258. Because the p-value is greater than 0.05, it shows the probability that the null hypothesis is true. The 2Ks, HSD comparison of means of the p-values, all the p-values are greater than 0.05. There is not significant enough evidence to reject the null hypothesis. The Levene's test and Shapiro-Wilk test of normality shows that the cost and destination of most popular Europe and least popular South America, because the p-value for the Shapiro-Wilk test is below 0.05, the goodness of fit test, there is means to reject the null. Data is not normal. The Levine's test, the p-value is greater than 0.05, which means variances are significantly different from each other, meaning that the dataset was too broad to really categorize the right amount of like cost per destination. I think this could be due to the continents that I changed it to, which is like each country has their own monetary cost value that you would travel to. And the fact that I like categorized it to the continent made a huge difference in comparison to each country in those continents. So it could have a lot of variances within that continent. It just shows a lot of variance within the data set comparing cost and destination. But this also can look at the figure 1G bar plot with error bars on destination in all the continents and average cost. The mean for most of these are all $2,000 or a little bit below $2,000, and I say that's pretty true looking at the data set. I would say Europe has the most standard deviation within that because of the fact that the error bars is the biggest for that, as well as the fact that Europe consists of so many little countries that all have different monetary values as well as different economic values that it would range depending on what country you go to in Europe. But the conclusion for this whole experiment was that the hypothesis there is no significant difference between cost and destination. Cost is relatively the same when traveling to different countries. Is the next one, there are 49% of males and 51% females that travel in the data set. This is in figure 2A. And in figure 2B, it shows that the bar plot of mean of age versus gender of travel population straight line cannot be drawn through male and female error bars, indicating that there is a significant difference between males and females and their age when traveling. The hypothesis, gender and age have an association for the dataset population is false because of the fact that they don't really play into a factor in the dataset. Like you could be a male or female and still have like the same they still have the same frequency when they travel. The next one is figures 3A and 3B. 3A shows a normal QQ plot, residual versus fit of age and cost to travel. The graph shows light-tailed for the distribution of residuals, and normality is satisfied. As age increases by 1.6551 years, the price increases by 3 to 8.61 USD dollars. Oh, in figure 3B, residual plot of age and cost out of the population of travelers shows that the mean of residuals is 0, which is satisfied. Most points are concentrated between negative 500 to 500 on the y-axis. There is a homoscedasticity of the residuals for a megaphone effect. There is an independence of the residual, which is satisfied since the points are scattered but conform to one area of the plot. This leads to the hypothesis the older a traveler gets, the more they spend on their travels, which is true. Which kind of shows, as the older you get, the more comfortable you want to be when you travel, which means you're going to spend a little bit more to just gain that comfortability. The messages and results for figures 4A, 4B is 4A shows a normal QQ plot, residual versus fit of cost and day duration of travel, light-tailed. For the distribution of residuals, the normality is satisfied. A day duration increases by 10.7 days, and that means that the price increases by 2,708.4 USD dollars. And then for figure 4B, it shows the mean of residuals is 0. It shows the residual plot of cost and day duration of travelers, which shows the mean of residuals is 0, which is satisfied. Most points are concentrated between y equals negative 500 and y equals 500. There is no homoscedasticity of the residuals since the residuals do not make a linear line. There is not an independence of the residuals since the points are scattered but conform to one area of the plot. As with my other hypothesis that the longer you stay on travel, the more it costs, which is true. The next one, 5A, 5B. Side-by-side bar plot of the destination with proportion to gender shows travelers going to South America 60% of women compared to 40% men. Travelers going to Australia, 54% women, 46% men. Travelers going to North America are 52% men, 48% women. Travelers going to Asia, 49% women, 51% men. Travelers going to Europe, 49% men, 51% women. There isn't really that much of a difference between like what gender you are and where you decide to go, which kind of just shows back to the first hypothesis that age and gender do not have a correlation within an association within the data set at all. It's a chi-square test of independence between the relationship of gender and destination. The test is 0.704845 and the p-value is 0.95073. The p-value is greater than 0.05, meaning that the null is not rejected, which means that hypothesis gender and age have an association to the dataset population is false. The methods and results for 6A, 6B, 6C bar plot of mean of cost versus gender of travel population. The straight line can be drawn through both male and female error bars, indicating that there is no significant difference between gender and mean of cost. Figure 6b is a test of equality variance of gender's relationship to cost. The F value is 1.877171 and P value is 0.010706996. The p-value is less than 0.05, meaning that there is enough variance to account for mean differences. Figure 6c, the t-test of the mean GPA of gender and cost. Test statistics is 0.308226 and p-value is 0.758422. Since the p-value is greater than 0.05, the results are insignificant, which means that gender has a role in determining how much you spend on a trip when traveling is false. The discussion for this part is the overall objective was to find a suitable new travel plan to spend my money on, and I think that we completed that. The studies applied an immense amount of analysis to be used to add significant cause of what destination, age, gender, and cost are important factors of travel, or if they have no association at all in the 2023 travelers dataset. I found that the average day duration of travel is 7.6 days, age that travels is 33 years old, cost is around 1,892.88 USD dollars. This is probably because the dataset was all over the world, and to travel to different countries is different in different continents, gets excessively more expensive. Figures 1D, 1E allow us to prove that there is no association between countries with more tourists and attractions. More popular continents, I will choose Europe, will have a higher price to travel to the countries on less popular continents, which I will choose South America. Since the p-value is less than 0.05, this was shown by not being able to reject the null hypothesis that there is no significant difference between the cost and destination, which supports the claim that there is no significant difference between cost and destination. The ANOVA test, figure 1D, relationship between cost and destination has a p-value of 0.300164 and f value of 1.23258. P-value is less than 0.0, is greater than 0.05, which shows the probability that the null hypothesis is true. In figure 1E, the 2K's HSD test comparison of means p-values of destination versus cost has all p-values greater than 0.05. There is not significant enough evidence to reject the null hypothesis. Therefore, there is no significant difference to where you decide to travel and the cost. It is all relatively the same. To answer my question if age and gender have an association with the dataset, it was proven the variances to not be significant. They are shown in figures 2A, 2B that gender and how old a traveler is does not play into the decision of traveling. It is relatively the same. Figures 3A, 3B shows the normality of the dataset that when age increases, so does money spent on the travel. As age increases by 1.6551 years, so does the price and increases by 328.61 USD dollars spent on the travel. The megaphone effect on the residual plot shows that there is a homostaticity of the residuals and there are few to no errors when doing the data analysis, which shows that age and cost do have significant association with one another, which backs up the claim to the hypothesis that the older a traveler gets, the more they spend on their travels. Figures 4A, 4B shows that the normality is satisfied where day duration increases by 10.7 days. The price increases by 2,708.4 US dollars. And so homostaticity of the residuals do not make a linear line. There is not an independence of residuals since the points are scattered but conform to one area of the plot. Removing the outliers on the residual plot could make the results homostatic. Figures 5A, 5B show that the female and male distribution in each continent is pretty much equivalent to each other. The null hypothesis shown cannot be rejected, shown in the chi-square test, since p-value is greater than 0.05, which shows that there is no association between gender and destination travel to the dataset. Figures 6A, 6B answer the claim made that gender has a role in determining how much you spend on a trip when traveling. There is an indication in the mean bar plot that there is no significant difference between gender and mean of cost. The test of equality variance of gender's relationship to cost F value is 1.87171 and p-value is 0.0107096. The p-value is less than 0.05, meaning there is enough variance to account for mean differences in the test statistic 0.308226 and p-value is 0.758422. Since the p-value is greater than 0.05, the results are insignificant, which can show that there is not enough evidence to reject the null hypothesis of gender does not have a role in determining how you spend a trip when traveling. And the fact that gender and age don't really have an association when traveling, so I can really go whenever I want. It's very encouraging.